So we've talked about the measures of location specifically to do with central tendency, the mean, median and the mode. So now we're going to look at some other measures of location. The ones we're talking about are more linked to the median than any others because they're all to do with percentiles along the data. The median, of course, is an example of a percentile. It's the 50th percentile. And at GCSE you met some other percentiles. You met the 25th percentile, and that's the lower quartile. And you met the upper quartile, which is the 75th percentile. But you can have any percentiles at all. So there are examples in different scenarios, especially in medicine, where people are interested in things like 10th percentiles or 90th percentiles. When they're talking about the weights of newborn babies, for instance, they compare newborn babies using graphs of percentiles to see how a baby's weight fits in with general distributions in the population. So what we're going to look at is how we can find the median and the quartiles, and this applies to any kinds of percentiles at all. We did already look in one of the last videos at the idea of finding the median using n+1/2, which is probably what you learnt at GCSE. What I'm going to show you now is an alternative way that you can apply to the median and the quartiles. You can use it for grouped and ungrouped data, and you just need a slight adjustment in the way you approach it depending on whether you are dealing with grouped or ungrouped. So, in order to find the lower quartile, or 25th percentile, we're going to take the number of items in the data set and divide it by 4. To find the 50th percentile, or the median, we're going to divide the number of items by 2. And to find the upper quartile, you've probably guessed this, we're going to multiply by 3 and then divide by 4. So we're finding 3/4 of the way along the data. But there's a bit of a caveat here. If you're dealing with grouped data, you can just use this outcome as it is and say it's in this position or this position or this position. However, if you're dealing with ungrouped data, you're going to do a little bit of an adjustment. And the same adjustment applies to all three. And the adjustment is this. If your answer here comes out to be a decimal, then you're going to round up to the nearest integer and find the value in that position. But if this comes out to be an integer, then you are going to take the value that's in the position that's halfway between this one and the one above. So find halfway between this position and the next. If you have group data, you don't need to do any of that, you're just going to stick with this. So before we go on to example 4, let me just show you with a really simple data set. Let's take the data set 1, 2, 3, 4, 5. So there are 5 items in this data set, that means n is 5, which means if I want to find the median, I'm going to go 5/2, which is 2.5. This is a decimal, so I'm going to round it up. So that implies that I take the 3rd position. So 1, 2, 3, that would be the median. So it gives me the same outcome as n+1/2 that we looked at before, but n+1/2 doesn't work if you're trying to find the lower and the upper quartiles, whereas this process works for all of them. So, but same thing for grouped and ungrouped data, but you have to take a bit of an adjustment when you're dealing with ungrouped data that you don't have to use when you're dealing with grouped data. So let's have a look at example 4. We've got ungrouped data here. This is from the large data set, and it's the daily maximum gust in knots on the first 20 days of June 2015 in Herne. Here's the data. We're asked to find the median and the quartiles. So we have got 2, 4, 6, 8, 10, 20 data values. So n is 20. So that means to find the lower quartile, to find its position, I'm going to do n/4. So that gives me 5. Now this is an integer. So I'm going to find halfway between this position and the next. So I'm going to find the value that's in 5.5th position, if you like, halfway between the 5th and the 6th. So let's find that now. 1, 2, 3, 4, 5, 6. They're both 18, so halfway between them is also an 18. Now let's do the median. Half of 20 is 10. This is also an integer. So we're going to find halfway between this and the one above. So we're going to find what's halfway between the 10th and the 11th positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's halfway between 22 and 23. So that's 22.5. And then finally, for the upper quartile, we're going to go 3n over 4, or 3/4 of 20, so that's going to be 15. Again, it's an integer, so we're going to want to go halfway between 15 and 16. So this the 15.5th position, that was 10, 11, 12, 13, 14, 15, 16, so halfway between 25 and 26. So the upper quartile is 25.5. So we've got our median and our quartiles for these data. Now, I haven't put the units on here, which is very remiss of me, so let's put that back on. 18 knots, 22.5 knots and 25.5 knots. And the reason it's important to keep the units is something that I've stressed in all the previous videos, and that's that you have to make sure you keep these numbers in context and that you understand the context of the data that you're given and the data that you're working with. So now we're going to have a look at what we do when we have grouped data. It's a little bit more involved here, because we're not just going to give the class that these are located in, like we did in the previous video. We're actually going to get estimates for the median, the quartiles, anything like that, using a process called interpolation. So let's make a little note over here, shall we, that when we've got grouped data, we use these values, but then we interpolate. And I'll show you what that means now. So first things first, here's our table, which is the length of time to the nearest minute spent on the internet each evening by a group of students. We've got some gaps between the end point of one class and the starting point of the next, so let's fill those in the way we've learnt. So this is really 29.5 to 31.5, 31.5 to 33.5, 33.5 to 36.5, and 36.5 to 39.5. I hope you can see that in my tiny writing there. Now, we're asked first of all to find an estimate for the upper quartile. Let's work out the position it's in. We need to know how many students were surveyed. We need to know what n is. That's the sum of our frequencies. So we've got 2, 25, 13, 13. N is 70. So 70 students were surveyed here. And the upper quartile is in position 3/4 of 70. That's position 52.5. We don't round it up, even though it's a decimal, because we only do that for ungrouped data, whereas this is grouped data. We're going to find or estimate the value that's in 52.5th position. Now, first of all, I want to know which of these classes it falls into. The first two values are in this class. So let's just make a little note of that. By the time we get to the end of that class, we've had 2 values. Now, by the time we get to the end of this class, we've had 27 values because a further 25. Now we've got a further 30 values, so that takes us to 57. And then, of course, by the end of here, we've got up to all 70 values. So the 52.5th value, or the value in 52.5th position, is somewhere in this class here. So what we're going to do is a little line diagram to help me picture what's going on. This class starts at 33.5 and extends to 36.5. At the start of the class, we had up to that point 27 values, and by the end of it, we had 57 values. And somewhere along here is the value in 52.5th position. So we're only going to put it roughly somewhere around there, 52.5. And that is our upper quartile, somewhere between 33.5 and 36.5 that we're going to find out. Now, the clever thing with interpolation is this. The fraction that this gap takes out of the entire class is exactly the same as the fraction this gap takes out of the entire class. So green over purple is equal to green over purple. So let's write that out as a calculation. And I'll get myself a new green pen for the next video. We've got Q3 minus 33.5 over purple, 36.5 minus 33.5. So that's the length of this gap over the length of this gap is equal to, now this green, 52.5 minus 27 over 57 minus 27. So let's simplify this a little bit. That gives us Q3 minus 33.5 over, that's 3, is equal to, that's 25.5 over 30. Now I've just got an equation to solve. Let's multiply the 3 over and add the 33.5 and we'll have our answer. So we've got 25.5 over 30. We're going to multiply the 3 up to here. That gives us 2.55. Now I'm going to add the 33.5 over. And we've got 36.05. Now, it is an estimate for the upper quartile because just like we've seen when we're dealing with group data before, we don't actually know what these 30 values are in this group, and we don't even know that they're evenly spaced. What we're doing is we're assuming that they're evenly spaced in order to work this out. So strictly speaking, I should be putting an approximately equal to on there. And let's think about our units. We're talking about length of time spent in minutes, so I'll write minutes on the end there. Right, we're asked to find the 10th percentile as well, so we're going to do exactly the same thing here. First of all, I want to know, we've got 70 data values. Where is this 10th percentile? We'll use this notation, P10. And to find out where it is, we're doing the 10th percentile, so we're splitting 70 into 10 parts. So we're finding 10% of 70. So that's going to be the 7th position. Let's come back to our table. First 2 are here. The next 25 are here, which means the 7th one is very early on in this class here. So let's do ourselves another little diagram. We've got the second class going from 31.5 up to 33.5. It starts with a frequency of 2 and ends with a frequency of 27. We're trying to find the value of the value that's in 7th position, so somewhere along here. That is our P10. So, same idea again. This gap over this gap is the same as this one over this one. So we've got P10 minus 31.5 over 7 minus 2 equal to, you can do it that way. Let's not do it that way because that's not the way I taught you before. Let's change that. P10 minus 31.5 over 33.5 minus 31.5 equal to 7 minus 2 over 27 minus 2. For those of you who are interested, have a think to yourselves now. You can work it out based on what you know on rearranging equations from GCSE. If I had done what I started to do there and wrote 7 minus 2, and then over here had put 33.5 minus 31.5 over 27 minus 2. Convince yourselves why that would have been absolutely fine to do, but I'll leave that as an exercise for you. Let's carry on with this. If we simplify it, running out of space, let's write this really small. We've got P10 over 2 is equal to 5 over 25. So our 10th percentile will be, we're going to have our 5 over 25. We're going to multiply it. I didn't even, let's try again. I didn't even write my minus 31.5 on there. Sorry about that. That's this one. I just forgot to transfer it across there. So 5 over 25 multiplied by 2 and then add the 31.5 and that gives us an answer of 31.9. And we are in minutes. Now you can do this process of interpolation to find any kind of percentile, which includes the median, and you just have to make sure you start off by using these ideas to find your position and then interpolating. So could you have a go at exercise 2C, please?